Hello, in this lecture we're going to talk about describing supply and demand. We're going to talk about elasticity, chapter 6. We'll start off with our quote from John Maynard Keynes, who is a very influential economist in the 20th century, and his quote is, "The master economist must understand symbols and speak in words. He must contemplate the particulars in terms of the general and touch abstract and concrete in the same flight of thought." So let's break that down a little bit and see if we can get a piece of what he is looking at in this case. So the master economist must understand symbols and speak in words. So you'll note that we're going to break things down into our models here. We're going to use a lot of symbols in order to analyze things and look at them scientifically as possible, apply reason to these models. In doing so, we really need to understand, of course, the models themselves, but we also need to understand and know how to present the information to other people. Note that knowing something is not everything, because if we know something and we can't communicate something, we can't, change the world with that. We need to convince others to do that. The way to convince others is through rhetoric. It is through words. And so a master economist really needs to be good at both of those things so they can both come to the conclusions that are reasonable based on the models as well as communicate those conclusions. He must contemplate the particular in terms of the general. So note that we are using a lot of general rules. We're going to use a lot of general ideas and concepts. And of course, we're going to see them in general. We're also going to try to apply them to the particular in many cases and touch on the abstract and concrete in the same flight of thought. So we're going to take a look at a lot of abstract ideas, and we're applying these abstract principles. And of course, we also need to then put those abstract principles into concrete use in many cases. So the end goal of many of the economic thoughts is to apply them to a real topic, a concrete usage for them. All right, so chapter goals. Use elasticity to describe the responsiveness of quantities to changes in price and distinguish 5 elasticity terms. Explain the importance of substitution in determining elasticity of supply and demand. Relate price elasticity of demand to total revenue. Define and calculate income elasticity and cross-price elasticity of demand, and to explain how the concept of elasticity makes supply and demand analysis more useful. Okay, so we're going to start price elasticity. We're looking at price elasticity on demand. So price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. We'll take a look at that calculation. We'll also take a look at this pictorially and think through what that means. So the formula will be looking like this. We're going to take the percentage change in quantity divided by the percentage change in price. This tells us exactly how quantity demanded responds to a change in price. So that's what we're getting at. What is the responsiveness to a change in price? We know that the general rule is that as prices go up, people demand less. If the price goes up of something, we're probably not going to want as much of it. If the price goes down, people are going to probably demand more. That's the general rule. Is there exceptions to the rule? Are there exceptions to that rule? There are, and we'll talk about those. Those are the more rare exceptions, but we'll talk about those in a bit. We're going to talk about the general rule now. That's the one that's going to apply most of the time. What we need to think about now, though, is how much is that response taking place? How much does a change in price change people's willingness to buy or not to buy? So elasticity is independent of units. We're not going to talk about elasticity, you'll notice, in terms of just units. We're talking about the percentage change here, and we'll think about the difference between that and just like the slope of the line. And price elasticity of demand is always expressed as a positive number. Once we break down this calculation, you'll note that it'll always come out to be a negative number, and so it doesn't have any purpose for us to have a negative number because it's a downward sloping line. So we just need to express it as a positive number. We can just say that as going to be the case, or we can put absolute values around it just to always have it come out positive. But just recognize, of course, when we do this, we'll come up with a negative number every time because it's a downward sloping line, and we will just have to recognize that we want to represent it as a positive number. Let's first take a look at how this would look pictorially, then we'll look at it in formula format, and then we'll look at it pictorially again. So over here we have two downward sloping demand curves. So here's this demand curve here, here's a demand curve here. They're downward sloping, meaning we have price on the vertical axis and quantity on the horizontal axis. And we know that as price goes up, so if we went from here to here, we can see that the quantity demanded would go down because at 30, people demand 100, And at 40, if the price goes up, people demand the 50. So that's going to be the normal thing for the demand curve. When the price goes up, people demand less. When the price goes down, people demand more. That's also the case over here, but you'll note that it's a lot less of a change. So that's going to be the idea of elasticity. So let's take a look at that for a second. If we just took the price of 30 and we were going to say, okay, 30 over here, if we hit the demand curve, people are going to demand 100 units at a price of 30. If we bring that all the way over to this item, people are going to demand somewhere right there. I'm not sure what the number is, but we can see it right here. If we move the price down to 20, then when we look at this demand curve, we go to the 20, and we can see that people now demand 150. So it's going up by 50 in this case because the price went down. If we scroll over to this line and we take the new price now at 20, you can see that there's a lot smaller change. So the idea being here that in this more flat sloping line, if there's a change in the price, there's a much greater change in the quantity demanded. It's more elastic. So if you think of a rubber band, you can see that we have less force. We can think in this case causes a greater stretch in the rubber band. In this case over here, we have the same amount of force in terms of price, meaning going from 30 down to 20, but a lot less change in the rubber band. It's less elastic. It's more inelastic. So that's the general idea pictorially. So you can see the extremes of this case is automatically will be a vertical line. If we took the extreme case, would be perfectly inelastic, and a horizontal line would be perfectly elastic. Probably will not happen in too many markets that way, but you can see if we took this model to the extreme, those would be the extreme. Now, if we took a more horizontal line, we can say, well, what kind of things would be more horizontal? We'll talk more about this in a bit, but generally, if we're in a market that has more trade and in a more perfect competition market, say we're selling our donuts again, if there's a donut shop up the street and a donut shop down the street, and they could substitute donuts for other things like danishes and whatnot, it might be that our change in the price will have a fairly large effect on the quantity. If someone can go somewhere else and very easily, then we change our price, very likely that someone will go somewhere else. Hamburgers are a common scenario for this as well. If you talk about Burger King, McDonald's, and whatnot, they're all fairly similar. So if someone charges a lot more for their hamburger than the other one, then probably someone's going to go somewhere else, and you'll have a big change in terms of quantity demanded based on a small change in price. It's interesting to see the other side of this as well. When we have these markets, what type of market would you have a change in price that has a very little change in demand? And that could be something in a place where there's not many people that could provide the good or service, and people need it really bad. And these are some interesting topics on that side when that scenario takes place. A couple things to look at that. If we were a pharmaceutical company and we were selling a drug that people needed for their health in order to stay alive, even to the extreme case, then if the pharmaceutical company changed their price and they have a patent on the goods, then people are still going to want to pay for it, even if the price goes up by a substantial amount, because they really, really need it. And this is a real problem in markets, because we have this problem in that, one, we want to allow the pharmaceutical companies to generate a profit in some cases, because that incentivizes people to do research and development. If they weren't able to make a profit on research and development on these extreme problems, then there's less incentive to do the research and development, and that's a problem. We want to let the market give incentives to cure these diseases. But on the other hand, of course, when the drug is out there and you've got people that really need it, there's a lot of legitimate social pressure out there that's saying, hey, we've got to distribute this at reasonable prices. You can't be gouging people that really need it. So note that there's a real problem on both sides of that. We don't want to discourage the creation of the drugs, and on the other hand, we really want to give the drugs out when they come out and they're available. So that's going to be one example. We have the same example with illegal drugs. If drugs are illegal, we have a black market for it, and we saw what happens when we have a black market. It could end up happening that there's less access to illegal drugs, obviously, and people that are addicted to illegal drugs, because they're addicted, may have a more inelastic curve here. So that means that they're willing to pay a higher price for it, and that means that people are willing to take more risks in terms of jail sentences and things like that to make the profit that goes along with the higher price in a more monopolistic market. So that's another example where we have this inelastic that could be worth thinking about and thinking of the pros and cons of each side. Another one is legal drugs. If we have alcohol and cigarettes, it's often thought that when we're going to tax something, we should tax alcohol and cigarettes. And that thought is that those will lower the consumption of alcohol and cigarettes, which could be the case because in economic thinking, we would think that people respond to incentives. But unlike donuts over here, it could be also more the case that alcohol and cigarettes are more of a inelastic good, meaning that people are addicted to them. So if you raise or lower the price on it, we may just be, and the people that are consuming alcohol and cigarettes are often lower income individuals. So we may actually be basically putting a tax on lower income individuals who are still going to end up paying it because it's an inelastic. And the last one that's interesting to think about, or not the last one, but another one that's interesting to think about is gambling. In a lot of states, we basically have restricted gambling. Restricted gambling to certain areas. But there is one area that has kind of a monopoly in some cases, and that's the state, meaning the lottery. The lottery is a form of gambling, and they've restricted all other forms of gambling. So there's kind of a monopoly. And again, that might be something where people have inelastic desire. So even though the payoff is really poor compared to the cost, people are probably going to still participate in it, and because there's no competition in it, the state could make a lot of money based on that situation. So now we're going to take a look at elasticity and do the calculations and look at it more in a calculated rather than a pictorial form. Demand is elastic if the percentage change in quantity is greater than the percentage change in price. So elastic demand is when the elasticity is greater than 1. Demand is inelastic if the percentage change in quantity is less than the percentage change in price, less than 1. So if we look at our calculation here, we got the percentage change in quantity and the percentage change in price. If we take a look at these 2 points from B to A, what is the price elasticity of demand between A and B? We're going to get this formula here. And I'm going to break this down for you a bit. And note that what we're not talking about is just the slope of the line. We're not just talking about the slope of the line, the rise over the run, or the relationship of the run over the rise. What we're talking about is the percentage change. And we'll break this one out. It might be easier to actually write this formula out rather than try to put it into something like Excel, because you don't want to write it out linearly. You want to basically work it algebraically. All right, so the first thing to note is this percentage change might be a little bit different than what we have seen before, the way it's being represented in this formula. So let's break this out a bit. If we're taking this point here, we're going from, in this case, 10 to 14. If we took a look at that, if we said 0.2 is 10, 0.1 is 14, if we thought about that in like revenue, if we went from revenue of 14 in one year and then 10 in the next year, if we take the difference, then we would take the 10 minus the 14. We would have a dollar amount difference. If we were thinking about revenue year over year, that would be $4 difference. If we took about the percent change, as it's often thought of, would be the change divided by the original number, the first point, which would be 14, and that would be the percent change. And of course, we move the decimal over 2 places, that'd be the percent change. Note that they have something a bit different here. They're instead of taking it divided by the original number, we're taking it and dividing it by the average between the 2 points. So let's take a look at the difference here just so we can see this. If we took the 10 minus the 14, we've got the 4, but instead of dividing the 4 divided by the original 14, we're going to divide by the average. So I'm going to calculate the average of the 2 points. This equals the average of 10 plus 14 divided by 2. The average of those 2 points is 12. The average between 10 and 14 is 12. So now we're going to take this equals the 4 change divided not by the original point, but by the average of the 2, or 12 in this case. So we'll do the same thing. We'll do the same thing over here. If we take the 26 and the change was from 26 and 20, then the difference is going to be the 26, the new point, minus the 20, the old point, means we have a change of 6. Normally, we would take that percentage change. We would take the percentage change, the difference, divided by the original number, which in this case is 20, the old number, and that would give us 0.3. And it's a slightly different over here. Remember what we're going to do in this formula. We're going to take the difference equals the 26 minus the 20. We got that same 6, but we're not going to divide by the original number. We're going to divide by the average of the 2 points, which equals the 26 plus the 20 divided by 2. We're going to take the average of the 2 points. Now we're going to divide that out. So this equals the 6 divided by the average of the 2. Okay, and so then now we're going to divide that out. So this is the numerator, 0.33. Denominator is 0.26. If we divide that out, we're going to say this equals a 0.33 divided by the 0.26. And there we have it. Now, I took it out to 3 decimals here because you'll note that because of rounding, this number would actually round to 1.28, and they rounded it to 1.27 because they rounded these two numbers as they went. If we were to just take this scenario, we would have the 0.29 over the 0.3, and so just keep the difference in mind of what is being meant in this formula by the percentage change, and take that average of the denominator. Now also note that this comes out to be a negative number. It's always going to come out to be a negative number. The fact that it's negative doesn't tell us anything significant. It doesn't do anything for us. It's never going to be positive. It's always going to be negative. It's kind of a waste of time to say it's a negative number. It just doesn't help anything. So we just say it's a positive number. We recognize when you do the calculation, it's always going to come out negative. We're not going to say negative every time. We're just going to say it's a positive number. We can represent that in a couple different ways. We could just say, hey, we're going to call it a positive number, or they can represent it with absolute values. Remember, absolute values means how many units from 0, and therefore it just basically flips the sign from a negative to a positive in this case.